You guys,
Okay, good morning,
morning.
good afternoon, based on where you are. I hope you can hear me clearly. My name is Victor Odari, the Vice President, AMRS, and today we are going to have a webinar. And our presenters today are, let me share my screen. So we have, I hope you can see my screen. So we have Professor Mike Davies-Coleman. We have Dr. Iain. Yeah, the second name is a bit tough for me to pronounce. Let me not say. But we have Dr. Iain here with us. You also have Antony Spagnoli here. And they're going to talk about empowering the next generation of chemists, enhancing technical and analytical skills through interactive digital resources. But before I allow them to introduce themselves and speak, I wish to welcome Samuel. Professor Samuel Chigome, just to say hi for a minute or less. Samuel, are you able to hear me?
Okay, okay, thank you, Victor. Can you see my screen?
Yes, I can hear you. Please
Hello, Victor,
proceed.
can you hear me?
Yes, yes, please
Okay,
proceed.
okay, thank you very much. Thank you to all those that have joined, and also thank you to our guest speakers. My name is Samuel Shugome. I'm responsible for the head office of the African Materials Research Society. We are based in Gaborone, Botswana. The African Materials Research Society, I could say that it is one main objective, which is to promote excellence in all aspects of material science. So we are a platform that seeks to bring together all the 54 countries so that we can see collaboration within Africa and also connecting Africa to the rest of the world. I'm also responsible for the first ever regional office in Africa of IUMRS, which is the International Union of Materials Research Societies. So with this, we connect the African MRS to all the global materials research societies. So these are platforms that we put together in an effort to create unlimited opportunities for our researchers in Africa in materials research. So this webinar is part of our monthly series where, because it's the office of African MRS and the office of IUMRS that are all based in Botswana, that we coordinate this, working together with Dr. Odari, who's the lead organizer of AMRS 2026 and the vice president. He's going to talk more about the conference. It's an effort to try and reach out to everyone on the continent so at least you can be aware of the different developments all over the world. So I want to encourage you to be available for these monthly webinars. We normally have them every last Thursday of the month. So if you happen to miss or you maybe get distracted somewhere along the way, we also have the webinars available on our website so you can refer to them. And also we'll be willing to connect you with the facilitators. So with that, Victor, I thank you and I look forward to the wonderful webinar that's coming up. Thank you.
Thanks, Samuel. And just a quick one. Uh, just as what Samuel has said, we are organizing our 13th International Conference of the African Material Research Society, called in short AMRS 2026. This will be held here in Kenya, Nairobi, from 5th to 10th December, where on 5th to 6th we shall have the pre-conference workshops, and we have quite a number that have been planned for, starting from crystallography, electrospinning. We have the coach workshop. We are planning for an AI in material discovery workshop and many others. And then the main event will take place from 7th to 10th December at University of Nairobi. The theme of the conference is Material Science and Innovation, Driving Sustainable Development and Socioeconomic Transformation in Africa. And we have around 10 symposiums, which we encourage you to submit abstracts and come and participate in. One of them is the biomaterials and materials for health. The others are materials for agriculture, materials for energy, materials for construction, building, infrastructure. We have nanotechnology. And for now, the symposium that has the most abstracts, that is materials for environment, water, and sanitation. But we also have others like materials in mining and mineral processing, advanced materials, materials for manufacturing, and then artificial intelligence, as I had mentioned earlier. And we are also planning some special sessions within the main event, and these include the AMRS EMRS Symposium, AMRS CMRS. EMRS stands for European Material Research Society. CMRS stands for the China Material Research Society. And we also have a symposium of the African light source. And we shall also have a session organized by the UNESCO chairs. So kindly scan our QR code or go to our website for more details of our conference. And also, I'd like to show you some of our keynote speakers that are coming for the event. And you can note that they represent almost all the continents. Some are from Europe, some are from Asia, from the US, we have Africa. So with that, I want to welcome you for the AMRS 2026. So with that, I want to welcome our speakers, Antony, Iain. Maybe they can start off. They'll start by introducing themselves, then go straight to the subject of today, the topic of today. So who will start? Is it Iain or Antony or Michael?
Hey, can you hear me?
Yes, I can hear you. Please proceed.
Yeah,
Thank you.
I'll start and I'll pass over to Anthony, then Mike. So, hi everyone, I'm Iain Thistlethwaite. It's a difficult surname to pronounce, so you're forgiven, Victor, for that one. I'm the partnerships lead at LearnSci. I'm a chemist by training. I did my undergraduate degree at the University of Glasgow and a PhD from the University of Bristol. During my time at Bristol, I also demonstrated in the teaching laboratories at their Bristol Chem Labs facility. This is where I initially came across the fantastic interactive resources that our company, LearnSci, was developing at the time. And that's when I saw the amazing impact they were having on the students in the labs. So that kind of sparked a passion for how we can use digital technology to transform science education. So that led me on to eventually joining the company LearnSci, which is where I've been for the last 12 years. And I've been involved in designing and developing a lot of our chemistry resources when I first started. However, for the last 10 years, my focus has really been setting up partnerships with universities, helping them to integrate these digital solutions into their own courses. So, yeah, if you're interested in what you see today, I'd love to connect with you and discuss how some of these strategies that we show might work for your own programs. So, yeah, please do connect with me afterwards if you'd like to follow up. I'll hand over to Anthony to introduce himself. Hi, Anthony. You okay to unmute? Yeah.
Yeah, sorry, it wasn't letting me unmute for a second then. Thank you, Iain. Good afternoon, everyone. I'm Antony Spagnoli. My background's more in bioscience. There is some cross-disciplinary stuff there when I studied molecular medicine. I've been working at LearnSci for the last 5 years, supporting our partners, both new and old, in terms of getting the resources set up, ready to help support students, and also making sure they conform to any plans and goals they might have had at their universities, whether that's supporting various practical labs, forms of assessment, those sorts of things. So I've worked quite intimately with various academics worldwide, really, in that space. I was actually introduced to LearnSci back when I had hair when I was a student. We actually had some of the resources in my master's. This led to me getting in touch with LearnSci, and yeah, the rest is history, really. I'll pass over to Mike.
Good afternoon, everyone. And Victor, thank you very much for the invitation to present to you. I am retired. I am an emeritus professor of the University of Western Cape in Cape Town and Rhodes University in Makanda in the Eastern Cape. I was the Dean of Science at the University of Western Cape for 10 years, and we introduced learning science, as I'll explain later, in 2020, just before the pandemic. And it's exploded across South Africa, and I'm still very much involved with learning science as an academic consultant, but I'll chat about that a bit later on.
Okay, thanks, Mike. I'm going to start off with a presentation, and Anthony's going to do some demonstration of some of our resources. So hopefully you can all now see the slides that I'm sharing on screen. Okay. Okay, great. So our webinar today is about empowering the next generation of chemists, and more specifically, addressing the challenge of scaling skills development on your chemistry courses without losing academic rigor. So this is a problem that all STEM programs face. And we're going to discuss today and show you how learning technology can play and is having a significant role in solving this challenge. So across the sector, we hear very similar themes. Most institutions tell us they feel stuck between two pressures, so scaling delivery of the skill development program, but whilst maintaining this academic rigor. Now, if you rely on workshops and manually marked worksheets, you can get a high level of control over that and take advantage of your faculty staff's experience and expertise, but with limited time and huge amounts of marking associated and feedback to give to students, it's very difficult to scale this approach. If you use simple quizzes or the tools available on your LMS, they do scale quite well, but they're shallow and they can't assess multi-step scientific reasoning required for the sort of complex data analysis and interpretation we want students performing. So they're limited in that way. You can build your own content, of course, or use AI as a lot of us do nowadays, and you get great flexibility with these approaches. But you take on a huge maintenance and QA burden. You also risk introducing scientific inaccuracies. So a lot of institutions end up having to choose between scale and rigor. And that's where LearnSci can help. LearnSci, we're different. We create all of our resources for university courses. They're created for scientists by science educators. They're validated by experts, and they're aligned to real laboratory practice. So LearnSci are an educational technology company. We're a team of scientists, professors, educators, and digital innovators. And for almost now 20 years, we've specialized in developing solutions for scientific skills development. These are used by over 200 university departments all over the world. And really, our mission is to remove this trade-off between scale and rigor entirely. And we do that by providing a comprehensive suite of tools and resources for technical and analytical skills mastery. We have our lab sims. So these are interactive, browser-based simulations that develop precision-validated technical skills. And we'll demonstrate some of these on the webinar today. We have our smart worksheets. These build multi-step analytical reasoning and scientific numeracy skills. Fantastic for getting students practicing all types of calculations, data analysis, and interpretation that they need to do associated with their labs and research. And together with our LearnSci analytics, these give instructors deep insight into student performance, engagement, and specific problem areas, allowing you to target your teaching interventions and identify the real areas where students need your help. So together, these create a seamless pathway from foundational skills right up to higher order scientific thinking skills. Let's talk first about our lab sims. We have a large library of lab sims covering lots of common lab techniques, procedures, equipment that students will be using in your labs. These simulations are focused on isolated core skills. They're designed and developed to complement and enhance your teaching laboratories not just to replace them. They're there to enhance that experience for the students. And the nice thing about the lab sims, they are precise and concise. They're repeatable, and students often go back and replay and work through the simulations multiple times to build their confidence, preparedness before they even step foot into the laboratory. They're highly interactive, really engaging, active learning. The students are problem solving as they work through these activities, making decisions, more like they have to do in a real laboratory where there's so many things they have to engage with and decisions they have to make. But this is a low stakes environment, a safe environment for them to practice. Now, all of our simulations go through a rigorous design and development process. You don't need to be concerned about scientific inaccuracies and things like that being introduced. We have a huge uh, group of subject matter experts who collaborate with our university experts, and we build and design our resources together. So they're really designed for you to use on your courses. You can trust the resources are built with that academic grade precision and scientific rigor. And they're really easy to use. One of the most important things about technology, if it's going to be successfully implemented and used, it has to be straightforward, it has to be simple. So they work within your LMS, whether you're using, Blackboard, Moodle, Canvas, or another learning management system. They integrate into that platform. Students just click on the activities and away they go. They can start working through the simulations. So really easy to set up. The other technology I'd like to introduce are the smart worksheets, the LearnSci smart worksheets. They offer students a responsive and interactive experience while they work through data analysis and numerical problems. So every student receives instant feedback automatically, and it's targeted to the mistake that they make. So they get that personalized feedback that they need right at the time when they're struggling, and then they can go and try again and improve on their answer. It's a bit like having a personal tutor to work with, but you can do that in your own time and at your own pace. Now, these worksheets have been designed purposely for science education. They can handle the types of questions that we want to ask students on these courses. The ones that you struggle to ask if you're using simple quizzes or native LMS quiz tools on your platform. So we can handle interconnected questions where we can build up really complex data analysis and interpretation problems. And again, all of this links into your own platform on your LMS. One of the really powerful things about using the smart worksheets is wherever possible, we build in randomization, random data sets, algorithmic data, algorithmic images, as you see on the TLC plate that is changing on your screen right now. So students can practice these exercises again and again with different questions, different data sets, different answers, but all of them will get that automated feedback and grading. So you can use these in all sorts of different scenarios. Now you've got that variation between each student attempt. So it also reduces things like opportunities for students to collude and copy answers. They're doing their own work and they have to work towards their own answers. Another huge benefit of the worksheets is obviously that they're automatically graded by the system. All of these questions, all the answers automatically graded, and all the feedback is automatically provided. So saving you, the academics, hours, days of time in terms of marking. So introducing the smart worksheets into your assessment strategy can really reduce your own workload. And the students love getting their feedback and marks instantly. We get lots and lots of student feedback about how great that feedback mechanism is. So it really works for both the staff and for the students. All the grades and everything from the worksheets also go straight back into your native grade center on your LMS. So really minimizing any administrative work for you. So those are two of the technologies that we use within our solution that we offer. And as I said, we also have our LearnSci Analytics where we can let you know through a dashboard which instructors can access at any time the engagement of your students, which resources are they using, when are they using them, how many times are they using them, did they complete them, which questions did they get right, which questions did they get wrong. We can drill down into that performance data and pinpoint where your students struggle. So with the smart worksheets, we can look at specific learning outcomes, topics, questions, and let you know how individual and also the aggregated analytics across your whole class, your whole cohort of students, how they're doing. This allows you to use your time more effectively. Rather than teaching them things they already know and understand, focus your time where they're struggling and where you can really help them. So this helps, prepare for tutorials and workshops and inform the teaching staff to understand your students much, much better. Now, this works across all major LMS platforms. So if you're using one of the platforms on the screen here, it's really simple integration. If you don't have a platform set up, we actually have our own platform. So there's lots of different ways that you can get access to this material and allow students and your learners to access these resources. And we have a team to work with you to set that up as well. I'd like to just briefly share some of the content that we cover, and then what I want to do is hand over to Anthony, and he's going to show you a couple of these resources so you can see exactly what the student would experience as they go through the activities. But within the chemistry, we cover many, many topics. So within scientific literacy, some of the really fundamental things you're teaching students, just skills around numeracy. There's huge issues across the globe in all universities at numeracy levels of students coming on to STEM programs. And it's a huge issue in terms of their progression through the course. So if we can help them right from the start with those skills, it really has a huge impact on the retention of those students and the success of those students, and also reduce that maths anxiety that many feel. So we have loads of resources around numeracy, things like unit conversions, calculations, using graphing and data presentation, but also things around, pH, solutions and dilutions calculations, some of the statistical tests that they're going to be doing. So really sort of fundamental things they can practice, and then going into sort of more analytical chemistry techniques around mass spectroscopy, infrared spectroscopy, NMR, spectrometry, chromatography, and other things there. A lot of the synthetic techniques you use in your lab, whether that's around separation, filtration, drying techniques, purification methods, simulations that can take the students through those procedures and give them some practice. And then lots of resources around physical chemistry, whether they're struggling with kinetics, thermodynamics, or titration, which I'm sure all of you are teaching, simulations and worksheets to help them in those topics. And then inorganic and organic chemistry as well. We've got many, many more resources across those topics there. I do want to highlight that we do support other areas of science. We are specialists in chemistry, biosciences, biomedical sciences, forensic sciences. So we're going to focus today on chemistry, but if you have colleagues or if you're teaching some of our courses, there may be a lot more in our catalogue that you'd like to explore. And I can certainly, set up trial access so you can try all of this content as well, and we'll come back to that at the end. But just for now, I'm going to stop there and I'm going to hand over to my colleague Anthony. And if it all is going well, he should be able to share some demonstrations. Hey, Anthony, you okay to share your screen?
He's on mute, probably.
I know that Anthony has had some connection issues today. So what I'm
Oh,
going to do is I'm going to just continue sharing my screen and we're going to come back to the demonstration. I'm going to give Anthony a couple of minutes just to sort out his internet connection. So let me just move on to my next slide. Can you all see my slides again? I'll just keep moving on.
yes, I can see. Can
Yeah,
see
fantastic.
it.
Okay, what I wanted to talk about next, just for a few minutes, is how we can take our students supported with the digital resources that I'm going to show you from, the technical foundations right up to the sort of the higher order critical thinking skills that we were trying to develop our students into scientists here. So before we can talk about mastering the mechanics of techniques, of course, we'll need to introduce students into the concepts of working safely in a lab citizenship. So we have lab sims on health and safety, cost risk assessment, and these offer a more engaging way to cover some of the content around your lab inductions that you'll be doing. Now with the simulations, what we enable students to do is a dry run through setting up all sorts of equipment that they're going to be using in the lab. So this can be a really key source of anxiety for students coming to the lab with maybe no experience of using the equipment. Maybe they've seen a demonstration before. It's always quite varied in terms of the students we get into the course, of what experience they've had on hands-on in the lab before. So this can really help just ease them into that laboratory environment. As well as performing some of the techniques, we can, build their confidence and competence by taking them through and visualizing some of the science that's happening around the equipment. So the simulations allow us to kind of open up the sort of black box and see what's going on and get students thinking about it in different ways. And having the extra confidence and competence coming into the lab, what we found it really reduces the issues in the lab and a lot of wasted time in the lab. So your labs will end up running a lot more efficiently as well. And another thing students really benefit from is practicing taking accurate measurements and precise measurements using lots of different types of equipment, different types of graduated glassware, and getting a better understanding of those different types of equipment they have in the lab. Finally, looking at different types of procedural error. So often the results you get, and more often than not, unfortunately, you don't always get the results you expect. So training students how to recognize, deal with those results, and work out maybe what had caused these unexpected outcomes. So giving students lots of feedback and practice around those. Then moving on to analytical competence. What our smart worksheets are really good for now is allowing students to work through collecting and recording data. Within the worksheet, they can manipulate that data, transform that data, and then perform some interconnected calculations. So in this case, I've just got an animation playing. So students are plotting data on a graph. Um, and the graphs and the spectrum in the smart worksheets are interactive. So the students can engage with those. And in this case, determine an unknown concentration of acid by titration. So they must interpret the titration curves and accurately record values using them. So a lot of our worksheets complement some of those titration labs and some of the concepts that you're teaching in there, whether it's the calculations or plotting these types of graphs. The worksheets can also help students, master the lab, maths, scientific numeracy. We really closely looking at sort of errors and significance, and students get lots of training and getting used to considering those aspects across all their calculations and data analysis. And moving on to higher order scientific thinking. An example here looking at NMR integration. We've got lots of amazing resources around different types of NMR and different examples and getting students practice on interpreting those, but with all of the feedback and support and scaffold of the smart worksheet. So getting students to analyze that, deduce what functional groups, assign chemical shifts and things like that. We also have lots of complementary NMR techniques like carbon NMR, depth NMR as well. So really useful resources in training your students in using these different types of techniques, really fundamental to the analysis of different types of compounds. So I think Anthony said he's back online, so I could pause here if Anthony wants to do a quick demonstration before I move on to the next part. Anthony, are you okay? Okay, I'll stop sharing and hand over the screen to Anthony. I still can't hear you, Anthony, though. Okay, what I'm going to do, just bear with me a second. I'm just
Like
going to share my screen again.
challenges.
Hey, okay. So I'm sharing my screen. So we have a large library of simulations, as I said, and this is our trial site, which we can give you access to, and you can play around with lots of these different resources. What I'll do is I'll just open one up, and I'm going to show you essentially what the student would be doing as they work through one of these exercises. So if I preview, I'm hoping you can see, just seeing what you can see on the screen. Can you see the simulation that I'm showing just now?
Yes.
Okay, so
No.
this is a reflux, which many of you will be familiar with. You probably do it in your research or in your teaching labs. So our resources are set up at the start by an inexperienced scientist. So what we can see is there are many, many issues the students must now think about and correct. You get feedback and help as you go through the resource. So on the right-hand panel here, we're getting some hints. So immediately I can see that there's no clamp on this setup and it's falling over. So we can put a clamp, we can drag this over and attach that to the setup and again check to see if that's solved any issues. Now, there's still 6 problems with this setup, so the student is then able to try again and modify something else. So for this instance, we can put some wire on the tubing. The water is actually going through this condenser the wrong way around, which I'm sure some of you will have noted, so we can correct that and we can check again. So I can certainly see the condenser working effectively, but there's still 4 issues remaining. The flask is far too small in this case. We can add some boiling chips to prevent some of that bumping. We've got the heat up to full, which is never a good idea. So I'm going to reduce this heat down a little bit and check this again. And I think there's still an issue here. A really big no-no. Let's not clamp the condenser because this is going to break lots of equipment. And one of the big things we want to train students is not only working safely, but really want to let them work so they don't damage, waste materials, waste equipment in your lab, and reduce the amount of money actually in running your teaching labs by training the students to be better. We can also get them thinking about things that they shouldn't do. So here there's a stopper on my workbench, and if I add this onto the apparatus, we suddenly see, that's a bad idea. So we can teach the students what to do and what not to do. So in this case, yeah, if I just remove that stopper, I think this now should be set up as we would like the students to set it up in our lab. So we've got the correct feedback. So there's an example of one of the simulations. We've got many, many more simulations that I could show you. Another one, which I certainly used a lot in my own research, and something that is very complicated actually to kind of understand when you first start using it, is a Schleinklein, so doing different types of reactions, sort of air sensitive reactions, and quite a complicated setup. And in this case, what we're able to do is show the students this graphical representation of the setup, which is more easier to understand, and then also show them a real life Schleinklein, something they might have access to in the laboratory. So students are able to switch between the two and hover over and get an understanding of each of these key different components. One by one, we're going to go into a separate page to let the students understand how to use each component. So I'll show you a couple of these, but first of all, the tap and understanding how to control the tap and what's happening here. So, putting some grease on this using flexible tubing, and then how rotating that tap either connects it to, in this case, to nitrogen or to the vacuum line. So visualizing that really clearly for students. In this case, it's asked me to connect it to the vacuum line and the instructions, so I can check that and make sure that's set up correctly. Next, we're looking at the oil bubbler. This is required to balance and monitor the pressure of the inert gas line. So we've got to adjust the settings now to this component to make sure it's set up safely and correctly. So we can put the tubing to the top or to the bottom. We can also have it closed or open the outlet. So let's try and get this wrong and see what happens. So you get really, interactive visuals here showing the students what you shouldn't be doing. So we can try all sorts of different combinations as well and seeing that operating correctly. Even look at the Dewar height here as well, or where to place that when setting up this particular apparatus, and a nice visual of what happens if you do that incorrectly. And then about sort of running enough cycles to degas the reaction flask as well, so we can simulate what happens, and then really clearly visualize in the flask what is happening as well to the students. So we need to optimize this a little bit further, but the feedback there again helps the students to do that. So that's a couple of simulations. I'm sorry if I've not been able to show one that is relevant to your own program, but you can explore all of these in your own time across the chemistry and the biosciences as well. Now, I think in the interest of time, I'm just going to pop back to my presentation just to get through to the end of this. What I want to move on to is something really important is, the ultimate goal is for your students to be confident and competent enough in their technical and analytical skills so they can apply them into any given scenario, something they've experienced before or something that is new. And the reasons our resources have been so successful is really down to four key pillars. They're really focused. As I said, we isolate the core skills rather than wrapping them in a story-driven simulation scenario. So they can be applied to lots of scenarios. So they're really flexible how you can introduce these into your own teaching. They're efficient. So in terms of the conciseness and getting information across to students, we have many, many things they need to be doing. So being able to learn quickly and efficiently using these resources is very effective, but also efficient in terms of the auto grading, reducing the staff workload. So both enhancing student and staff experience. The authenticity is really important. So the fact that we've worked with educators, subject matter experts, and it's grounded in real data applied to the context that students are learning makes it really authentic to their learning experience and the responsive nature of them, the responsive nature of the resources, but also they enable you to be responsive and flexible in your teaching practice. The LearnSci analytics giving you those insights, access to the library of resources that you can bring in quickly to your teaching without having that additional burden of having to create content from scratch. So the libraries are the starting point. You have a fantastic set of resources ready to use on your course. But more importantly is the strategic use of these. And our team work very closely with all of our university partners to work on the implementation strategies. This is a big thing that we work on. We have worked with many universities successfully achieving their goals by thinking really carefully about how we introduce the technology. And we also do a lot of educational research around that to evidence these approaches, which we'll come back to. So these are something I'm really interested in talking about. What are your goals? What are your challenges? And how can these help? And how can we, our team, help you to deliver and address those challenges and goals? One interesting way you can use the content is by mixing up different resources together. Curate your own assignments from lab sims and worksheets. Supplement and enhance your existing teaching material. We're not talking about replacing. We're not talking about throwing out your course, throwing out your labs. We're talking about how can we enhance this with some of the best technology and best resources around that universities can access for science. We work in partnership with many, many universities. Obviously, today we're hoping to introduce this to many, many more. We work a lot in Africa, in South Africa in particular, and I want to leave Professor Mike Davies-Coleman some time to talk about that. But we'd love you to be part of this community, part of this collaboration, and introduce you to some of the fantastic educators that we're already working and collaborating with. Now, some of the impacts we've seen across our universities. One example here, Sheffield Hallam, changing the way they do their lab assessments and lab courses, introducing some marks for pre-lab engagement, so introducing pre-practicals where students have an engagement mark for just completing them, and the knock-on effect this has on the lab test grades, all increasing. Working with the University of Queensland in Australia to help them with the pass rates on their foundational courses, introducing weekly quizzes using smart worksheets to really help the students understand where they're performing well and where they need to practice more, and also keeping the academics up to speed on where their students are struggling. Working with the Cardiff University, introducing authentic assessments whilst reducing marking burden. So fully automating some of their assessments, their skill-based assessments, which used to cost staff a lot of marking time, days and days of marking time. Working closely with the University of Brighton, we've reduced and in some cases eliminated awarding gaps between different student cohorts across many different science subjects. Finally, in KwaZulu-Natal University, where we've worked for a long time, working closely with academics there to introduce really effective pre-laboratory digital exercises using lab sims and worksheets to build confidence and preparedness, and the transformational impact that's had on the labs has been really phenomenal there. So this is an evidence-based approach. It's peer-reviewed and it's sector validated. It's already used widely across our partnerships. And wherever possible, we publish the educational research that we collaborated on and the literature. So it's all evidence-based, and we continually improve the resources that we develop based on the latest research. So I've got a few quotes from students. I've got so many quotes I could include from students, but really, this is who we're doing it for, to improve their experience, to help them understand these concepts, to help them stick with the science program right to the end and succeed in their course and their goals. So it really helps all different types of students, especially ones that find it easier to cope with this type of resource when they have ADHD, anxiety, dyslexia. They can really engage with these types of resources, and it helps them to understand lab protocols, helps them to understand some of the numeracy and topics they struggle with. Now, I'm just going to finish my slides just now, just with an explanation of the next steps. If you want to get involved, if you want to find out more, we have different licensing models that work for different types of universities, different types of departments. You get access to our libraries with an integration into your LMS. As part of this, we support you fully in terms of training, onboarding throughout the year in terms of making best use of our resources. And Anthony, who unfortunately has had some internet issues, he's a key part in that process in terms of helping you make the most from our resources. We can work with you to align it across your curriculum, and we also continue to update that. You get all the updates that we include throughout the year. So last slide, if you're interested, I'll pop my details and links in the chat. But if you scan this QR code, it takes you to a sign up form. We can send you free trial access so you can go and play around with some of the content. And you can also get in touch directly with myself by email. I'm happy to have a one-to-one meeting with you, discuss your own department needs, and we can take it from there. But I'm gonna finish there, and I want to make sure I leave enough time for Mike as well for his talk. But I'm happy to take a few questions just now if there are any questions.
Okay, Iain, you want me to carry on?
You can do. I'm just check the chat. If there's any questions, please pop them in the chat. Otherwise, I'm going to hand over to Mike. I could always. There's a few questions on the chat.
There is the last one that came through was that how you compare simulated labs with actual labs. It's very important to note
Hmm.
that these are not a replacement for laboratories. These pre-lab simulations. I think we've all tried mind maps. I think we've all tried quizzes. I think we've all tried getting the students to write a short summary of what the prac's about, and none of it works. They'll still come in ill-prepared. And so what I'm going to talk about is how we've handled this at South African universities, which are, I'm sure, universities across Africa now are very similar in the students that we take in. Many of them not having any access to laboratories at school, and it's very much like that here in South Africa. So you want me to continue, Iain?
Yeah, I'm going to stop sharing, Mike, and then if you're
Okay.
able to share your presentation.
Okay. So as I mentioned in the brief introduction that I gave, I'm a former Dean of Science at the University of Western Cape, and we struggled a lot with students being not particularly prepared for labs, majority of them, and terrified. Terrified that one student once said to me, "I'm so glad you've got these labs simulations." Or we didn't say to me, we heard yesterday because they at a presentation we gave at the Cape Peninsula University of Technology. One of the feedbacks we got from a lecturer was the students using these programs said they're so glad that they got them now because they thought they were going to die in the laboratory. Okay, so some students are very scared, others just don't know what to do and they don't want to break anything. So and I'm sure this is a picture that's probably similar to all of you across Africa, that we have so many students and we have equipment, and the equipment we have a lot of the times is not working, or because of the student pressure, there's too many students around, say, for instance, a microscope. So what we have done, we picked up the major laboratory challenges for me have always been lack of confidence. I think if students are confident in the laboratory, they will be very successful. We all have, and this is not uniquely South African problem, but we all have increasing numbers and decreasing budgets, and I'm sure you can all relate to that. There are very real health and safety concerns across the continent. We have limited laboratory equipment and resources, and that's very, I'm sure that you all suffer with that, and also limited space. So we thought that preparing students thoroughly before laboratory practical sessions could be key to addressing these challenges. And in 2020, we partnered with LearnSci. I have had a long collaboration with the School of Chemistry at Bristol University in the UK, and LearnSci came through their Chem Labs development from 2008, so almost 20 years ago. So some of you may know Fanelwa Jai from the Department of Chemistry at UWC. The virtual labs have really helped supplement the real laboratory practicals. Please, it's not a replacement. It just supplements the laboratories. And students who've done the simulations have been calmer, more confident, and even more independent. And even though they're first-year students, we've seen a lot few breakages as well. And I'm sure many of you manage laboratories, so you'll appreciate this slide. I just did some homework on what it costs to replace the standard quick fit distillation kit. So I've turned it into US dollars. So it's you probably follow Rand's dollar exchange is probably not familiar to you, but so in US dollars, $70 for that kit in South Africa in 2020, and now it's $306 for the same kit in 2026. And you can appreciate that our budgets, and I'm sure you went through the same process I did when I was dean, is that we just don't have budgets increasing by 100% in 4 years. So when we started, it was just before the pandemic. So we could use these pre-prac simulations to keep our students engaged with the laboratory, so that when they came back and we had to do a massive crushed series of practicals to catch up, that they were better prepared because of the simulations. So we've used both the chemistry and biosciences lab sim libraries and smart worksheets in South Africa. And these are the several universities that have and are currently using the smart worksheets and lab sims. So the next question is we always ask ourselves is how do the students access these? So we've just finished a big research project at Rhodes and Rhodes University in the Eastern Cape and the University of Western Cape just outside Cape Town. And I was particularly interested in how are the students accessing these programs, and they can access them on cell phones effectively and on laptops. And there's quite an interesting difference between the two universities that we were doing the research at. At the University of Western Cape, which is an urban university and difficult for our students to get to, for most of our students, cell phones was the preferred choice. And at Rhodes University, in a very small town in the Eastern Cape, the students can walk to a computer lab and do the program and access the resources there. So that explained, I think, this difference. So the question then we ask ourselves is, how are they used over the period 20 to 24, so 2020 to 2024. So if you look at this at the bottom line, you'll see that South African university students and staff accessed the LearnSci chemistry library a total of 344,000 times. And each time the students are registered, they become a unique user. And so you can see when you look at the numbers that they are accessing these multiple times. And if you think about library journals, I'm sure you won't have any journal in your library that's accessed 350,000 times, well, across a country at least. And in the biosciences library, a little less uptake, but still 172,000 times from a smaller number of unique users. What has been interesting when we looked at the last year over 2025 was the explosion of activity at the University of KwaZulu-Natal in Durban and Pietermaritzburg. And you can see then their access by 2,660 users was 94,000 accesses. So 2,660 users, that staff and students, logged on to Learning Science programs 94,000 times. This was the highest total access to LearnSci resources by any university in the world in 2025. So these work in Africa. They really, really work here. So I'm interested to monitor the progression of access from the University of KwaZulu-Natal, and these pie charts give you some idea how they've just exploded their use. And the reason is you've got to have a champion, and this is the champion at the University of KwaZulu-Natal, and I'm sure if you contacted her, she would give you all the information you need about how to integrate the lab sims and smart worksheets into programs. Vino's main interest is first year chemistry, and she found that the simulations, the students enjoyed working with them. So there's some feedback from the staff member, and it makes them think about the apparatus and understand the link between theory and practical aspects. And I'm sure all of you who teach, that is our goal, is to try and link the theory and the practice. So Learning Science, and Iain didn't mention this, they also have Teaching Innovation Awards, and if you use these resources in a innovative way, you can submit a short summary of what you've done, and it goes to a judging panel, and they give 3 or 4 of these awards out every year. And Vino won last year. And it's what the judges said that I would like to focus on, which is the innovation offers a clear, inclusive, and pedagogically grounded solution to a well-documented challenge in first-year chemistry by intentionally aligning pre-lab activities with learning outcomes and embedding them directly within the learning management system. Dr. Padea created a structured and highly accessible environment for student success. So then you might be interested as to what programs are the 6 most accessed programs, for instance, last year. And you can see the simulations on filtration, melting point analysis, thin layer chromatography, recrystallization. So everyone has a different access. You'll notice there are simulations and videos. The difference between a video and a simulation is very clear. Students go into laboratory, have a number of decisions they have to make, and they come thick and fast. If you just watch a video, you have 2 decisions: switch the video on and switch the video off. So I see personally the advantage of lab sims is multiple decision points, similar, mimicking what you will see in the laboratory later on. You can't just go through a simulation without having to make a decision. And the bonus is you can make a decision that is wrong and there's no penalty. There's no broken glassware, there's no injury, there's no wasted solvents. So from that point of view, they stand out head and shoulders above anything else that I have seen in terms of laboratory preparation. We also have been using the resources as a research tool for the scholarship of teaching and learning, and also to give us really fundamental understanding of how the students are coping. It is so important that the students entering Chemistry 1, there's a gap for many of them in basic numeracy knowledge, their understanding of various aspects of mathematics that is of importance in chemistry. They may have the skills, but they can't apply them in chemistry. There's a whole lot of issues there. And it's important, we felt, to be able to identify them as the students enter Chemistry 1 and start to gear our workshops and tutorials to where the major gaps are. So I'm sure you can all relate as material scientists to these basic mathematical skills that we expect our students to be able to do when they enter into chemistry or into any scientific discipline. And so this is what the worksheets are set up to do. And we can analyze the students as they are working through the worksheet individually. We can see when we analyze the results, what areas they are particularly weak at, and we can target that immediately. We can find students at risk instantly. LearnSci is a very potent dashboard that you can get all of this information in real time. And there's nothing else that I'm aware of that gives this information so in such detail and with such precision. So here's some feedback from the students in terms of how they found them helpful. Green means a very dark green, very helpful. And you can see the different skills we were trying to explore: displaying numbers, ratio and percentage, scientific units, averages and spread of data, rearranging and solving equation, and graphs. We found, like all students all around the world, that graphs are a real issue for our first year chemistry students. So the question is, how did they rate the challenges? And there were 730 students. We got ethics approval for this project, and we had 730 students agree out of 1,000 and something to be part of the project. And we asked them a number of questions, and we got tremendous feedback. Over 700 of those 730 gave individual feedback on this course, and we're busy writing this up for the Journal of Chemical Education. But you can see that the students felt that it was about right for them. Most of the students at Rhodes University on the left and UWC on the right. And then the big thing is, would you recommend this to other fellow students? And you can see that the vast majority at both universities felt that they would highly recommend it to their colleagues doing similar courses. And then some feedback from the students. Practice makes perfect. The scientific numeracy was helpful to me. And the advantage of these smart worksheets is that the students, every time they access them, they get questions stay basically the same, but they get different numbers, they get different things they have to consider. So even if they're working in groups, they're all going to be looking at different worksheets. And from that point of view, they're all starting to learn in multiple ways. Also, too, we give the students an opportunity to, if we're doing it as an assessment exercise, to go back and repeat it and repeat it and repeat it until they get their highest mark that they feel happy with. And they just then are getting different questions they're having to deal with. So it's a tremendous self-learning exercise. And you can monitor how many times they access it. You can monitor when they access it, and all of these things remotely. It helped me realize that there are indeed many things that I don't fully understand and give more attention to. No comments, but I'm really impressed with the layout of this worksheet since it almost covered everything we did during lectures. This was from Rhodes University, where they had started teaching simultaneously. It really helped me in nailing significant figures. The significant figures in the smart worksheets is particularly well done, and the students who do it come back and say, I understand it for the first time. And then also from a revision point of view, these smart worksheets are wonderful for revising. They can go back and go back and go back and revise what they don't know. At the end of the smart worksheet, as I think Iain demonstrated, it comes up and lets the student know which areas they should look at, because they are potentially not grasping it as fast as they would want to. And it is a bit difficult. If it was really easy, the students wouldn't find it valuable. It keeps them thinking, which today is a very good exercise, and better understanding. At our discussion yesterday at the Cape Peninsula University of Technology, the students were saying, you know what? This is much better than AI, because we have to focus on this, and we have to think, and we enjoy thinking. And I think in today's generation, to enjoy thinking is the key for us educationists. And that's all I need to say. And thank you for your attention.
Thank you so much, Michael, Ian, and I also know Anthony in the background, though he had some challenges, which we understand. But Ian was there to back him up. Thanks a lot. Thanks for the discussion. Thanks for taking us through Learn Science, telling us about the lab sims, the smart worksheets. We've actually learned a lot from it. And I'm sure we have quite a number of questions from our participants. So if you have a question, kindly raise your hand, and then we will give you a chance to ask. So as you wait for the questions, let me start with the most challenging one. Is it an open source software?
Hey, no, unfortunately it's not open source, but what we do is we work with lots of different types of universities, mainly some other types of organizations. And once we understand what your specific circumstances, needs are, we can usually align, a license to access what you need for within the types of budgets that you're working with in your particular circumstances. So it's definitely something to follow up with us on. So they are costs involved in setting up a license, but there's lots of options, and that's what I'm interested in speaking to you maybe more individually about.
Thank you. I can see Lawrence is here with us. Lawrence, please go ahead.
Yeah, so I guess I see an application for even more advanced topics. So I'm thinking like curve fitting for spectra that you might get from a laboratory instrument or from a synchrotron, and also the sample preparation. So do you think it could be useful in that regard? And I imagine there are two sort of training levels. There has to be training for faculty to create these sort of didactics of like what are the failure points and what do you have to normally correct for, and then the training level for the student participants themselves. Do you help with the former, with the faculty training?
Yeah, great question. So, a lot of the resources that you've seen today and that are in our libraries are definitely sort of some of the introductory foundational level where the students are coming in and learning some of these skills for the first time. There's other resources which are slightly more advanced that they might move on to in years two, year three, or some of the postgraduate sort of master's programs they might be doing. We have also developed other resources and programs and courses for different training needs, outside of higher education. And certainly in upskilling teachers in some skills as well, which maybe they're not so familiar with that they are teaching. Um, so yeah, definitely something we've supported before. The main parts of our library, I would say, are geared towards the undergraduate programs and master's programs in terms of student skills development. We're always developing new content, I should say that. The resources we have are evolving all the time. We've got a new platform in development, which is very exciting. So we're always interested in new ideas, new areas to expand. We have recently developed a really advanced set of resources supporting clinical biomedical science, so medical laboratory science skills, and they're much higher level. You're training practitioners to be working in clinical settings. So there's lots of different projects we're working on at different levels. It's we don't cover everything. There's so much we want to do, but we kind of specialize in certain areas. So yeah, I don't know if that answers your full question, but I'm happy to kind of continue the conversation and share access to some of our materials so you can see the different types of things that we offer.
Okay, I'll contact you.
Thanks, Lawrence.
Okay, maybe another question as we wait for other questions from participants.
Victor, if I could just comment um, just on that last query, there is a smart worksheet on how to use smart worksheets for the students, which they have to do. It's very short, very easy, so they understand. And the dashboard that they've developed for staff, a short tutorial on that for multiple staff members, and they'll be flying. It's very, very user friendly.
Great. Now that you have materials scientists here, I know you have materials chemists, materials physicists here. Are you planning to expand to other disciplines?
Yeah, I mean, we haven't nailed down exactly what topics we're covering over the next several years. We've been developing different areas over the last year, particularly in the sort of biomedical sciences, within the forensic sciences. But we're always taking requests and suggestions from our partners, and it's an ongoing collaboration, really, how we continue to develop these resources. So, the my message to you today is to get involved, get in touch, and we can see what we can do through collaboration and through partnership.
Okay. Do you have a trial version of Learn Science that maybe some can try for a few months?
Yeah, so I've shared some stuff in the chat earlier on. I could probably reshare that message. So let's just send this. There's quite a lot of links I think I sent. I don't know if everyone can see that right at the top of the chat. Um, So there's a form that you can fill out that comes straight to our team, and then we can essentially give you access, a username and a password for a trial site where you can log in, try the lab sims, try the smart worksheets, and then once you've had a go, we can set up a call and answer any more questions you have around that. So I've just shared the message in the chat again. It's got a link to our website, a link to the product brochures with some more information about those different types of resources, the free trial sign up form, which you can click on. I've noticed that 3 or 4 of you have already filled out that form. I've got your requests. I'll be responding to you as soon as I can. Some more case studies, which I didn't have time to go into today. Some more on the educational research as well. We've got a web page dedicated to all of the research that we've been involved in terms of collaborations and also independent research by some of our partner institutions. So that might be of interest for some of you to look at as well.
Thank you. I don't know whether I have other questions from our participants.
Yeah, just what Mike was saying, I've just realized that I probably should have answered that a little bit better. But in terms of, onboarding for staff and training, I briefly mentioned that's all kind of inclusive in terms of what we offer. Anthony, who's on the call, and of our colleagues, and Oliver in the team, they work very closely to kind of with training. But really, you can just get up and running with this stuff straight away. You don't need to have any dedicated training sessions. It's a really kind of a couple of steps to get up and running. These introductory resources for staff and for students. So yeah, really straightforward. So if you want to get involved, it's really simple to do so.
Maybe another question. What are the challenges that you are facing in taking this land science across Africa, given that I've noted that you are working closely with South Africa, but not so much with the other countries? And how can
Yeah.
we as AMRs help?
Yeah, great. Well, you've helped by inviting us to give this webinar today, which really thankful for you to give us access to some of your membership and network. I hope it's been valuable for people to see this. But really, a lot of our partnerships have started through referral, word of mouth. Seeing the impact that Mike's team had at UWC and sharing that with universities around South Africa very quickly led on to other universities taking it on board and using it. And it's just, we haven't actually really been working in many other countries at the moment around Africa. However, over the last year, we have been speaking to more just through our other networks and people that we know. And we've started a number of pilot studies. Some are in the middle of those, some are finished around different countries. So we're getting a lot of feedback from those pilot studies, a lot of positive feedback, a lot of enthusiasm to kind of move forward towards partnerships. So, again, it's an invitation to other institutions who would like to try the resources. We can look at sort of pilot programs and things like that, and you can see it working in your own institution. We can get feedback from your own staff, from your own students, so you can really see how this would impact your courses, not just see how it's impacting other universities. We want to give you the opportunity to see how this can really have an impact on your own program. So yeah, the challenge is just setting up the meetings with the right people, and getting, I think Mike talked earlier about having product champions, someone to champion it within the department to start with, who we can work really closely with to set this up and to show it working. Mike's probably got something to add as well. Mike?
Yeah, very much so. So I just from a UWC South Africa perspective, I chaired the National Science Deans Forum for a while, so I was able to share good practice and people took it up. We have contacts, and I'm so thrilled to see Sam. After all these years, I think I taught Sam, or Sam was at Rhodes, but at the same time I was there. It's all word of mouth and getting to know people. We've been at several international conferences around Africa. People have been interested but haven't really followed up. I can thoroughly recommend the relationship with Learning Stars. Starts with a pilot of a year. You get a year to try it because we can't convince managers to invest in these long-term partnerships unless we have real data. So working with LearnSci, they come in, they support, they get it up on your learning management system before you actually launch it, make sure it works. So you call the staff in, get some champions from each department, and away they go. And you're given a year to try things, insert them in the course, ask the students what they think. And at the end of the day, we've managed to spread the partnership around South Africa, but we'd love to spread it through Africa. It really has transformed how we teach our students practical and theoretical chemistry and biosciences here in South Africa. So it's got a big thumbs up from me.
Great. I can see a question from Grace Gubeni in the chat, and her question is, how different is this from similar softwares like Cengage?
Yeah, okay. So, I mean, Cengage are a very different sort of company to LearnSci. So we are a smaller company and we are a lot more focused, entirely focused on science skills development within, the subjects that we specialize in. So what we offer is sort of really a dedicated set of resources for those topics. And indeed, we have actually worked with Cengage over the years and other companies. So in fact, in the United States, Cengage do actually license our simulations because they are considered the best in the class. So they will actually use our simulations in some of their software packages. Likewise, Macmillan Learning also license our smart worksheet technology in some countries for use within some of their software packages. But what we offer is the whole library of simulations and worksheets, and that direct support with our kind of team. So it's a really much more sort of personalized partnership in terms of how we work directly with universities. It's a very different experience to working with big publishing partners, which the feedback I've had from staff who I've worked with both big and smaller companies, indeed LearnSci, is they really value the feedback, the responsiveness of our team. We truly listen to what our educators and partners say, and we're very agile in terms of responding to that feedback, whether that's doing some edits, customizing content, adding in new content. We can be really flexible in how we support you, and I think that's something that you get from a partner like LearnSci, whereas maybe opposed to some sort of bigger publishing partners, which have a lot more to deal with than what we're focusing on. So yeah, there's maybe lots of different ways to answer that question, Grace, but hopefully that's helpful.
Great. There's another question in the chat. Have you presented LearnSci to FASChem?
Yeah. Well, we
DMB?
actually, really exciting, did come to the Commonwealth Chemistry Conference for the first time, and it was a fantastic conference. We met many, many inspirational educators, and we followed up with lots and lots of people from that conference. I believe that was Mike was with me there as well. Was that last year? Time is flying, but I believe we went to that last year. We're really interested to attend some of the other conferences. Certainly got our eyes on some conferences around Africa for next year. So hopefully opportunities to maybe meet some people in person, visit some universities as well if we can while we're visiting. Um, but
Maybe
yeah,
in addition to that, we
Lawrence, if
can.
you're, I'm happy to follow up with anyone who has sort of conferences and events where maybe they think it might be useful for us to participate, present, or get involved with. We're always happy to support events, especially where we're promoting and sharing best practice around education. We support many, many events across not only in the United Kingdom where the company is based, but around the world. We like to support the events, and not just the really big ones, but these smaller, really impactful educational conferences that we run.
I think we can also partner with AMRS when it comes to presenting in conferences like AMRS 2026. If you're interested, we can engage and see how we can reach out to the 400 plus participants that we're expecting from all over the world. Could be a platform for you, but that's
Yeah.
a discussion that we can have on the side.
Yeah, sounds great. Okay.
Anyone else with a question? I know we are 15 minutes past the hour. Anyone?
Yeah, thanks for sticking with us. If anyone's got any other questions, just get in touch by email. Uh, sign up on the drop form that we put there. I'll get back in touch, and we can follow up with you that way if you'd prefer.
I think you can share again your contacts before we close so that those with questions and have not taken your contacts can do so. Otherwise, I want to
Yeah,
thank the three of you. I want to thank Iain, I want to thank Antony, I want to thank Michael for creating time to come to the AMRS webinar. We don't take it for granted. We want you to reach out to most of our members so that they are familiar with what you do and they can pick the best practice with the aim of promoting material science in Africa. And it will be great if we partner together, not just for webinars and conferences, but for much greater things as AMRS and Learn Science. And with that, I want to thank all participants for creating time for this meeting. And let's look forward to our next webinar, which will be the last Thursday of the month of August. We will share the details with you. And for Iain, Antony, and Michael, we can as well have conversations of how to engage further after this conference, after this meeting, maybe via email, and we can pick up from there. So with that, thanks to everyone and goodbye.
Okay, thank you. Goodbye.
Thanks, everyone. Bye.
Thank you. Bye.